Okay, honors chemistry fans, this is lab 20, stoichiometry in action. In this lab, you're going to actually be able to use the stoichiometry we've just been practicing on paper, and we're going to do it using a very simple reaction. It's a reaction between sodium hydrogen carbonate, that's right here, and hydrochloric acid, HCl. Sodium hydrogen carbonate, there's another name for that, which we commonly call baking soda. So if you've ever put together baking soda and say maybe vinegar in your house, you've seen what happens. Sometimes we use that to create kind of a volcano effect, lots of bubbling, foaming, fizzing. So instead of vinegar, we're going to use hydrochloric acid as is shown in this equation. And we're going to use the baking soda. And if you take a look at the products, they're rather harmless. They're things like salt, sodium chloride, and carbon dioxide. That's where the bubbles come from. And then some good old-fashioned water. So once the carbon dioxide bubbles away, all you're really left with is salt water. So we take something that's pretty corrosive, some hydrochloric acid. If you look down in your equipment and materials section, you'll see that it's 6 molar hydrochloric acid. It's pretty strong stuff. It's about half of the concentration that we buy it at, so please be careful with that. If you spill it at any time, let me know so I can clean it up. Now, before you come to the lab, you're going to be given a certain amount of salt that I want you to produce. So since salt is one of the products, we want you to be able to produce the salt right here in a given amount. This is what they do in the pharmaceutical industry. If I want to produce a certain amount of, say, ibuprofen, Advil, and I work for Pfizer Pharmaceuticals, over the course of the day I have to figure out, well, how much of my reactants, how much needs to be put together in my laboratory so that I do not waste anything and that I have enough of each reactant so that I produce the appropriate amount of product. So before you come to lab, the day before you have lab, I'm going to have you pick a number. Pick a number out of a hat, you and your partner, and you're going to be given a certain amount of salt to produce. That is going to require that you do some pre-lab calculations. I'm going to skip ahead here to the top of the second page. Here are the pre-lab calculations I'm talking about. You're going to use that certain amount of salt that you picked, that number in class the day before, and you're going to do some calculations, 2 calculations really. The first one is to calculate how much sodium hydrogen carbonate you need to produce this much sodium chloride. It's a mass calculation. That's going to go right here. Pre-lab calculation number 1. Pre-lab calculation number 2 is to calculate the amount of hydrochloric acid that you need to go along with it. To help you with that calculation, I've given you a hint here. This is under pre-lab calculation number 2. Here's where you're going to do your work. Here's the hint. The molarity, which is the concentration of that hydrogen chloride, the hydrochloric acid solution, is that there are 6 moles per 1,000 milliliters of solution. So give that equivalent a try in your stoichiometry calculations. If you struggle with that, I'll help you before you start the lab. I'm going to want to see these pre-lab calculations before I let you start the lab anyway. So when you come into lab on lab day, I expect to see these 2 calculations at least attempted, if not completed. Once I sign off on those, then you can go ahead and you can start the procedure, which follows right after. Sorry about that, right here. There's even a picture of the procedure in your setup so that you have a good idea of what you'll be putting together, and the directions are pretty straightforward, so I'm going to let you follow those at your own pace and as you are ready to in lab. Now there's one thing that's different in this lab. I go back to the first page because you'll notice that 5 points of this lab are going to be awarded based on your results, and I'm talking about accuracy here. If you have this whole table kind of gives you an idea of accuracy. If you have a really highly accurate experiment, you're going to get nearly 100% yield. So let's say I ask you to make 2.5 grams of salt, sodium chloride. If you weigh your product at the end of the lab and you have 2.48 out of 2.5 expected grams, that's pretty high. That's a high percent yield. In other words, it's the opposite of percent error. So what we're looking for is really low percent error, which translates into a high percent yield. And I'm giving you a range here so you know what you're shooting for. Anything above 97%, you get 5 out of 5 points. Anything between 94 and 96, you get 4 points, and so on. If you've performed the lab and let's say you have an accident, you tip your product, you lose some of it, you measure wrong, who knows, and you're not happy with your results, I will let you do it once after school. You get one extra try after school. This will be after break, so it will probably be on the 25th, I believe that is, of February, that Thursday after break. So I'll confirm that date with you in class. Most of you won't need it. That's your challenge, is not to have to redo the lab after school. Most of you will not need that. You're good in lab. So here's your data table on the third page. Your theoretical yield, that's the number that you pick in class, so you'll be able to record that and use that to do your calculations. The rest of your data goes in here, and I think you're ready to do lab. Good luck!